أعزائي الطلبة وطلبة الصف الأول الثانوي، السلام عليكم ورحمة الله وبركاته. أهلا بكم في الجزء الثاني من حل الأسئلة الاسترشادية لنماذج الوزارة، نماذج امتحانات الوزارة. Number 6, question 6. In the opposite figure, AC intersect BD equals H. AC, line segment AC, intersect line segment BD equals H, point H. And the measure of arc AB equals 50. Measure of arc CD equals 40. Measure of arc CD equals 40. Then sec angle AHD equals one of these, root 2, negative root 2, 1 over root 2, negative 1 over root 2. Solution. First, we calculate measure of angle AHD. AHD. We wanted to find the first measure of angle AHD. And we have a rule for this. Measure of angle AHD equals half measure of arc AB plus measure of arc CD. This is the rule. So we substitute. We have half measure of arc AB equals 50, measure of arc CD equals 40, 40 plus 50 equals 90, multiply half, which equal 45. So we have measure of angle AHB equals 45. But the required is to find the angle AHD, and the angle AHD plus angle AHB both equals 180. So measure of angle AHD equals 180 minus 45, which equal 135. So sec 135 equals 1 over cosine 135, which equal 1 over negative 1 over root 2, which equal negative root 2. And the solution is B, negative root 2. Measure of angle AHD equals 135. But the required is to calculate secant angle AHD. Sec 135 equals 1 over cosine. Sec, it is the reciprocal of cosine. So sec 135 equals 1 over cosine 135, which equal negative root 2. If f of x equals x squared plus 2kx plus 5k minus 4 is always positive in R, then find the value of k. Solution. We have f of x is always positive. It means f of x has no real roots. What that mean? When you draw the function of f of x, when you draw the curve of the function f of x, it will not intersect x-axis at any point, and it will be above x-axis, and it will be drawn above x-axis. That means the curve will not intersect x-axis, so it's always positive. So this equation or this function has no real roots. That means b square minus 4ac is less than 0. And we have a equal 1, b equals 2k, and c equals 5k minus 4 from the function. A, it is the coefficient of x squared, equals 1. B is the coefficient of x, it's 2k, C, it is the absolute term which equal 5k minus 4. And we have b square minus 4ac is less than 0. So we substitute. We substitute b equals 2k. So we have 2k power 2 minus 4 multiply 1 multiply c, such that c equals 5k minus 4. All of this is less than 0. And 2k power 2 is 4k power 2 minus 4 multiply 1 multiply 5k. It is 20k. And negative 4 multiply 1 multiply negative 4 equals positive 16. And this is less than 0. And to simplify this inequality, we divide by 4. So dividing by 4, we get k power 2 minus 5k plus 4 less than 0. As 4k power 2 divide 4 equals k power 2. Negative 20k divide 4 equals negative 5. 16 divide 4 equals 4. And 0 divide 4 equals 0. And we put k power 2 minus 5k plus 4 equals 0 to find the zeros of this equation. K power 2 minus 5k plus 4 equals 0. And we factorize it. K power 2, it will be k multiply k. 4, positive 4, it is negative 1 multiply negative 4. So k minus 1 multiply k minus 4 equals 0. Then k equal 1 or k equals 4. K equal 1 or k equals 4. And we draw the number line for 1 and 0 to check the sign of this equation. The required is to find the interval that k power 2 minus 5k plus 4 is less than 0, negative. And we choose some numbers between 1 and 4 and before 1 and after 4. When k equal 1, then f of k, this function, will be 0. And when k equal 4, this function, try it, f of 4 will be equal 0. And we take number less than 1, like 0, and substitute in this form. Substitute k equal 0. We have 0 power 2 minus 5 by 0, 0 plus 4, it will be equal 4. And 4 is positive. So in this interval, the sign of this equation will be positive. And we write it. And we take another number lies between 1 and 4. And we substitute k, for example, equal 2 or 3. You will get a number, negative number, and we put that sign, negative, negative, negative. And we take another number is greater than 4, like 5, and you substitute here. What you get? You get a positive number. We write positive. So k belongs to open interval 1 and 4. So the values of k, which makes the inequality is true, which makes k square minus 5k plus 4 is less than 0, this number must be included between 1 and 4 and not equal 1 and not equals 4. So k belongs to 1 and 4. And this is the values of k, which makes x squared plus 2kx plus 5k minus 4 is always positive. Question 8. If x equals 2i power 2 minus 5i power 3 and y equals 2 over I power 3 plus 5i power 2, then prove that x minus y equals 3 multiply 1 plus I. Solution. First we simplify x. Since x equals 2i power 2 minus 5i power 3 and I power 2 equals negative 1 and I power 3 equals negative I. So x equals negative 2 plus 5i. I square equals negative 1. Negative 1 multiply 2, it is negative 2. And I power 3, it is negative I. Negative I multiply negative 5, it will be positive 5i. And we simplify y. Since y equals 2 power I power 3 plus 5i power 2, and we can put 2 as the product of 2 multiply 1, and 1 is I power 4. So we substitute 2i power 4 over I power 3 plus 5i power 2, and I power 2 equals negative 1. Again, 2 equals 2i power 4 as I power 4 equals 1. And you divide, so we have y equals 2i power 4 divide I power 3 equals 2i. 5 multiply negative 1, it is negative 5. Now we have the simplest form to each of x and y. Then x minus y equals, we substitute x equals negative 2 plus 5i minus the value of I in the value of y on its simplest form, 2i minus 5, and negative 2 plus 5i minus multiply, here we consider it negative 1, so we have minus multiply 2i, it is negative 2i, negative by negative, it is positive 5. Now negative 2 plus 5 equals 3, 5i minus 2i equals 3i. By taking 3 as a common factor, we have 3 multiply 1 plus I. So we have x minus y equals 3 multiply 1 plus I. Next question. Question number 9. In the opposite figure here, we have AB is parallel to CD is parallel to HO parallel to LM. Again, AB parallel to CD parallel to HO parallel to LM. And we have AC equals CH equals HL. AC equals CH equals HL. Then find the value of each of x and y. We will use Thales theorem, and we write, since AB is parallel to CD, parallel to HO, parallel to LM, and the included parts or the intercepted parts here is equal, then the intercepted parts on the other straight line also equal. It means BD equals DO equals OM. BD equals DO equals MO. What is the value of BD? BD equals x power 2 plus 2. We write it equals MO, and the MO equals 3x plus 6. So we have this equation. X squared plus 2 equals 3x plus 6. It means x power 2 minus 3x plus 2 minus 6 equal 0. Again, x squared minus 3x from right hand side to left hand side. We change the sign. Here is positive. In the left hand side will be negative. Plus 2 minus 6. Then x squared minus 3x. 2 minus 6, it is negative 4 equals 0, and we factorize it to be x plus 1 multiply x minus 4 equals 0. Then x equal negative 1 or x equals 4. Then BD equals x squared plus 4, which equal 4 power 2 plus 2, which equal 18. And the DO equals 18 centimeters. Since DO equals 18 centimeters, then 6y, DO equals 6y. So 6y equals 18, and y equals 18 divided 6, which equal 3. In the opposite figure, circle M represented the unit circle. Find in terms of the trigonometric functions of theta the coordinates of the point D. So the required is to find the coordinates of the point D. Solution: let the coordinates of the point D x and y. Here x and y. So x equals MA, x equals the length of MA, which equal 1 unit, equals 1 unit, because this circle is the unit circle from the given. And y equals the length of AD. Y equals the length of AD. Again, x and y is the coordinates of the point D. X equals OA, which equal 1, equals MA, which equal 1, and y equals AD, and we'll try to calculate AD. And M is a unit circle. Then tan theta equals opposite over adjacent. Tan theta equals AD over MA. AD over 1, which equal AD. So tan theta equals AD. Then the coordinates of the point D is 1 and tan theta. As x is 1, y equals AD. And we proved that AD equals tan theta. So the coordinates of the point D is 1 and tan theta. Don't forget that the required is to express the coordinates of the point D in terms of trigonometric functions of the angle theta. So the coordinates 1 and tan theta. 11. In the opposite figure, MD is a tangent to the circle N. MD is a tangent to circle M at the point D. At the point D. C is the midpoint of AB. Where is C? Here is C. is the midpoint of AB. It means AC equals BC. And AB equals 2MB. AB equals 2MB. And from that we can deduce that MB equals half AB equals AC equals BC. So we can deduce that AC equals CB equals BM, and we will use this in solution. Then find the length of MD. What is the length of line segment MD? Here we have a question mark. Solution. MD power 2 equals MB multiply MA. MD power 2, this is the required. MD power 2 equals MB multiply the length of MA. This is a rule. Again, MD power 2 equals the length of MB multiplied by MA, as M is a point lies out the circle. And we have AB equals to MB. It is from the given. AB equals to MB. So MB equals half. MB equals half multiply AB. And half multiply AB, half AB equals AC, also equals BC. So we can write MB equals AC equals BC. So these three parts are equal. MB equals AC equals BC. But we have DH intersect AB equals C. Back to the figure. AB intersect DH equals the point C. Then we have a rule for this. AC multiply BC equals DH multiply HC. Again from the figure. AC multiply BC equals CH multiply CD. Again, AC multiply BC equals DC multiply HC. AC multiply BC equals DC multiply HC. And we substitute DC equal 4 and HC equals 16. We get 64. Then the product of AC multiply BC equals 64. But BC equals AC. Then we can write AC power 2. Again, BC equals AC. So we can consider AC multiply AC again equals 64. So AC power 2 equals 64. By taking the square root to the both sides, we have AC equals 8 centimeters. Now we have AC equals 8 centimeters. Also, BC equals 8 centimeters and MB equals 8 centimeters. Back to the required. We have MD power 2 equals MB multiply MA. What is the length of MB? It is 8. What is the length of MA? It is 8 multiply 3. So we write it. MD power 2 equals 8 multiply 3 multiply 8 equals 192. It means the MD equals the square root of 192 equals 8 root 3. And this is the required. The required is to find the length of MD. So MD equals 8 root 3 centimeters. Question 12. In the opposite figure, ray AB is a tangent to the circle N at B. Ray AB is a tangent to circle N, the circle whose center is N, at the point B. And AH equals HD. AH equals HD. M is the midpoint of HD. MH equals MD. And CM equals 1. The length of CM, the length of the line segment CM equals 1 centimeters. And the length of MB equals 4 centimeters. Here, find the power of point A with respect to circle N. And we have a rule for this. PNA equals AB power 2. The required is to find the power of the point A with respect to circle N. And this is equal AB power 2. AB power 2. So, we will calculate the length of AB as follows. Let DM equals MH equals X. We have these two parts are equal. So we consider the length of each of them equals X. And we have AH equals HD. AH equals HD. AH, the length of AH equals the length of HD. Each of them equals 2x because HD equals 2x. So AH also equals 2x. HD intersect CB equals M. This is given. HD intersect CB equals the point M. And M is the point lies inside the circle. So we have a rule for this. DM multiply HM equals CM multiply MB. What's the length of DM? DM equals X. And the MH also equal X. Again, DM equals X and the MH equals X. So we multiply. X multiply X equals 1 multiply 4. As CM equals 1 and the MB equals 4. So X power 2 equals 1 multiply 4 equals 4 and the X equals 2. Then AB power 2 equals AH multiply AD. AB power 2 equals AH multiply AD. This is another rule. AH power 2, the length of AB power 2, the length of AB power 2 equals the product of AH multiply AD, as A is a point lies outside the circle. So we substitute. What is the length of AH? AH equals 4 and AD equals 8. You know that DM equals MH, H equal 2. So DH equal 4. 2 plus 2 equal 4. And we have DH equals HA. So the length of HA is 4. So we substitute AH equal 4 and the length of AD equals 4 plus 2 plus 2, which equal 8. So AB power 2 equals 4 multiply 8, which equal 32, and the AB equals root 32, which equal 4 root 2 centimeters. This is the length of AB. Back to the required. The required is to find the power of the point A with respect to circle N, denoted by P A to N. Then PNA equals 4 root 2 power 2, which equal 32.